request if audience have any questions, they can write down and send it and I will just try to summarize their presentation in few words. Regarding the presentation of Mr. Dolling, he has given a brief overview about the Siemens experience to successfully cope with the challenges concerned with the upgradation of new OHE. Focus of the presentation has been on the overhead contact line or OHE encompassing the process from design to installation, including maintenance. Using the examples of electrification of project Denmark with Siemens SX OCL system, possible approaches to optimization was presented. It has been discussed as to how the classic OHE can also be upgraded for the speeds of 160 to 200 km per hour. Modern software tools such as Seat Dynamics has been discussed. Similarly, the software Seat Master has been discussed for creation of layout plans, material schedules, optimization of spans and tension lengths, etc. The software tool of Seat CanDrop is also used for calculation of dropper lengths, cantilevers and components, clearances. He also discussed the mechanized construction of OHE, how it can be done, simulation and behavior of pantograph and contact wire, and the optimization costs and life cycle costs. The presentation of Mr. Otero describes the experience of Spain in high-speed rail with standard gauge that must coexist with the conventional BG, which is 1.668 meters there, which is comparable to the BG of Indian Railways. There has been shift of passengers from other modes to HSR since the starting of the railway. HSR has contributed to energy efficiency, safety, time saving, greenhouse gas reduction. There has been a reduction of CO2 emissions by 50% since 1992 when they started the HSRs. Spanish HS trains, they use the high-speed network standard gauge and the other conventional network, which is BG, without stopping at the interchange points. Over 25 years, savings of carbon dioxide emissions of 13 million tons have been achieved. Energy savings of 108,000 billion gigajoules have been achieved. Noise and accident reduction has also been achieved. They have a BG network, high-speed lines of 3,200 kilometers by upgrade and 2,600 kilometers of new construction. Smart metering on energy management and regenerative braking, which is sent to the grid or stored by the accumulative devices. Then energy consumption of high-speed train is less, which is a very important point he's made as compared to the conventional train, considering their frequent stopping and starting. One more point which is of interest is that the EBITDA of HSR is positive as compared to the conventional trains, which is seems to be unbelievable otherwise. Smart grid and smart traction power systems concepts have also been used. They have also been working on the government-to-government agreement for feasibility study of Mumbai-Kolkata via Nagpur. Simulation of energy savings over the Thane-Nasik stretch has been done. Feasibility study has been completed for phase 1 of Mumbai, that is Thane to Nagpur, for the total 770 kilometers with design speed of 350 kilometers per hour. Time reduction from current 15 hours 10 minutes to 3 hours 34 minutes. So this is in nutshell they have presented. If there are any questions. If there are no questions, there was one question received by Mr. Thil. Would you like to answer?
Can you hear me? Yeah, okay. So the question is, how would the hauling capacity of existing 25 kV railway track increase with when raising the specific power from one of the locomotive from 1 kilowatt per ton to 3 kilowatt per ton for freight trains, and from 3 kilowatt per ton to 10 kilowatt per ton for passenger trains. I cannot give a numerical answer just like that, because it depends. The answer depends on the track profile you consider, on the actual speed of the trains, and which is used on the respective line, and then on the number, also on the train sequence. Do you have a frequent mixed passenger and freight trains with relatively high frequency, so that a freight train has to stop very often to let pass passenger trains, or is this not the case? If it is the case, then as the faster the freight train can run, the farther it gets in between two passenger trains. So I think the case needs to be simulated, taking into account or considering a specific line and specific trains, and making a scheduling pattern. Then you can figure out. But I cannot give an answer which is generically true.
Please keep it.
Well, yes, it's okay, yes. The question is related with what is the size of the Catenary sorry, in high-speed section. Well, we started 25 years ago with a design, a Catenary provided by Siemens, and was 120 square millimeters. And this, because in this first project, maximum speed was only 280 kilometers per hour. But we can say that for us, Catenary, the overhead cable, is not a critical point of high speed. In such a way that in this Madrid-Sevilla, that we have celebrated 25 years experience this year, we maintain the same cable without need of replacement. So it's the test of the cotton, we said that it's working well. And now ADIF has developed our own design of category with 3 Spanish companies, is able to 350 kilometers per hour. This catenary is a mix of copper and magnesium, and the section is higher. It's 150 square millimeters. You know that why we are not running faster on on conventional lines? Because we have direct current, and the limit of direct current is 220. Because I really like vibration on the cable behavior. But in this case, working with this kind of categories for high speed is not a critical point. It's is not a technological risky decision. And the second was substation capacity. Now we are running with 2 per 30 megavolt amperes in each substation. We have using, of course, intermediate auto transformers to get the maximum distance between substations. In total, 60 megavolt amperes in the total of substation.
Okay. Thank you.
Thank you. Now, with this, we conclude the session. I am thankful to Khurana sir and to all the speakers for giving the wonderful presentation. I am thankful to everyone. Thank you.